Now that we have seen a way that we can design our algorithm, or a way that can help us to clearly represent our logic to solve a problem, it is also important to know which method you can use to write the actual program when you are following your algorithm design, or when you are following your algorithm. There are two popular methods I'd like us to look at it here. The first one is structured programming. Now, in structured programming, what we do is when you are being given the problem to solve, you break down the problem into smaller problems that you can sometimes refer to as modules. And depending on the size of these smaller problems or the modules, you may sometimes break it down further into smaller modules that we can refer it to as units. Now, in solving the smaller unit, you will end up solving the bigger module or the modules, and in solving the modules, you end up solving the bigger problem. And so we sometimes refer to structured programming as top-down design. You start from the top, you break it down all the way into smaller problems. So you're going to have something like a tree. Or we refer to it as bottom-up design, because you start solving the smaller problems all the way up on that tree. Or we also call it stepwise refinement. This is to say that with every step that you break down, you are actually refining that problem into a smaller unit which can be solvable. And another word that we use to represent structured programming is modular programming. That is breaking down the bigger problems into modules. So that is for structured programming. Another method that we use is object-oriented programming. Now, in object-oriented programming, we try to identify the various objects within the scope of the problem that we've been given. Okay. Now, these objects will represent a real-world entity that can perform an action within that problem. So let's use an example. Let's say that you want to write a software that can be used to manage hospital record or hospital management system. When you are dealing with structured programming, you look at the various modules, you break it down into modules. So you will say, okay, fine. For a hospital, you may want to have OPD records. You may want to have consultation room. You may want to have laboratory, pharmacy. And when you look at these modules, okay, they are big in themselves, they are big. So when you go to OPD records, you want to break it down into smaller units, or you want to break it down to sub-modules, which we refer to as units. The first one, you may want to have something like patient registration. You want to do maybe barcode scanning and taking of vitals. So that will form all part of OPD records. When you move to consultation, we also have smaller units. You may have clerking, diagnosis, prescriptions, you may have investigation, and so forth and so on. But in object-oriented programming, what you would do is identify the various objects, entities within that scope that can perform an action. So you would say a patient. Now, when you pick a patient, you think about it this way. What are the properties or attributes of a patient? A patient will have a name, will have an ID, date of birth, primary contact, and all that. Now, what can a patient do? A patient can take vitals. A patient can take vitals, can take procedure, can do all sort of things. Another object that or entity that you may want to pick out from the hospital scenario is a doctor. What are the properties of the doctor? The doctor will have an employee ID, will have a name, date of birth, a role, which is the doctor, and what can this doctor do? What are the actions of the doctor? Can do clerking or can perform clerking, do prescription, ask for investigation to be done, or a procedure to be conducted on a patient. And these objects, they usually interrelate. Okay, now let's look at another example that I've broken down here. Let's say that you want to write a simple program that allows you to use your finger to write on a touch device. First of all, the problem here is you want to write a program that behaves like a stylus. So how do you break it down? You break it down into modules. You have the write module, erase, display, export, convert. And then under write module, you have submodule or unit. And then here we have choose color, then scribble. When you get to object-oriented method, you identify the various objects within that problem. So the first thing you identify is stylus, the writing tool that you are going to use to allow your finger to write on the device. What are the properties? You are going to have ink color, that is so that you'll be able to select any color that you want. The size of the stylus, the type, whether it's going to behave like a pen, pencil, or that calligraph tool. The status, whether it is writing or it is idle. And then the action that they can perform is to write. So here you state all the action this object can perform. Then another object that we can identify is eraser. These are the properties or the attributes of the eraser object: the color, size, or status. The action the eraser can perform is to erase. And another object is the canvas. You may have the background color as an attribute, the size, the shape, and then the status, whether it is being written upon or not. Now note that these objects or entities, they relate to each other. The stylus will write on a canvas. The canvas will display and can export or convert the writings into text. The eraser can erase what have been written on a canvas. And this is how we go about OOP. And these two are popular methods that we use in computer programming. And OOP is widely used as compared to the modular programming or the structured programming. Well, as we move through this journey, we'll get to a point when we look at object-oriented programming in details. Alright, this will bring us to the end of lesson 2. But before you leave, I have an assignment for you. This is going to be assignment 1. You are to represent the coconut milk algorithm in a flowchart and pseudocode. I'll put the link to the file in the description. So you check the description and download, and then you do this assignment. That will be the end of this lesson. In this lesson, we've looked at what an algorithm is. We wrote a simple algorithm. Now you should be able to represent an algorithm in a flowchart, represent or write pseudocode representation of an algorithm. In the next lesson, we will continue with basic elements of C++2. We will look at arithmetic operators, operator precedence, expressions, and continue with type conversion or casting. If you enjoyed this lesson, kindly subscribe to this channel for more lessons. Thank you. See you in the next lesson.